Hello guys, welcome again sa ITS, Information Technology Skills. In this video, we're going to talk about CPU scheduling algorithm in operating system. Dito pag-usapan natin ng first come first serve or first in first out, shortest job first or SJF, priority scheduling, and of course, round robin. So first, what is CPU scheduling? CPU scheduling is a process in which allows a process to use CPU while the execution of other process is on hold. Ito yung tinatawag nating waiting state due to unavailability of any resources like the I/O, thereby making full use of the CPU. The aim of CPU scheduling is to make the system efficient, fast, and fair. Okay, so of course, kapag hindi naman ginagamit yung isang process, gagawin niya na yung isang process para walang natetenga or para lahat ng process is magamit. So these are the important terms or terminologies that we're going to use later on as we move on with the CPU scheduling. We have the burst time or execution time. It is a time required by the process to complete execution. It is also called as runtime. So we have there the keyword execution time. So ibig sabihin guys, ito yung time na magagamit ng isang process para ma-execute siya. Then we have the arrival time. From the word arrival time, it is when the process enters in ready state. So we have different states of a process. Kung hindi nyo pa alam yung different states of a process, lalagay ko yung link sa description box or dyan sa taas ng screen nyo para mapanood nyo the different states of processes. We also have the finish time, when the process completes and exits the system. Another important term is the multi-programming, a number of programs which can be present in memory at the same time. We also have the jobs. It is a type of program without any kind of user interaction. User, it is a kind of program having user interaction. Next, we have the process. So, parati natin napapakinggan tong word na process na to. So, ano big sabihin ng process? It is a reference that is used for both jobs and user. We also have the CPU or I/O burst cycle. Characterizes process execution which alternates between CPU and I/O activity. CPU time are usually shorter than the I/O time. So we have classifications of CPU scheduling. Meron tayong tinatawag na non-preemptive scheduling and the preemptive scheduling. Ano nga ba yung non-preemptive? If once the CPU has been assigned to a process and the process starts executing, the CPU cannot be taken away from the process. While the preemptive scheduling, even though the CPU has been assigned to a process and the process is already executing, the CPU scheduler may decide to assign the CPU to another process in the ready queue. So, para mas maintindihan yan guys, pag sinabing non-preemptive, kapag may nagra-run dyan na process dun sa CPU, tatapusin yun ni CPU. While the preemptive, kapag may nagra-run na process pero may dumating na mas high yung priority, pwedeng tanggalin yung process na ongoing nagra-run and ilalagay niya yung isang process na may higher priority. So, para mas maalala nyo, for non-preemptive, we have the N and P na keyword or letter, and for no, P, putol. So, non-preemptive, no putol. Preemptive, may putol. Basic. So, another term na pwede nating mapakinggan later on as we move with the CPU scheduling, we have the turnaround time. The interval from the time a process is submitted until it is complete. That is the definition of turnaround time. So, how do we compute turnaround time? We have the time finish minus time arrival. So, later on, mas maintindihan yung turnaround time kapag mayroon na tayong mga examples. So, don't forget to subscribe and hit that notification bell para mapanood nyo yung iba pa nating examples about CPU scheduling. We also have the response time. For an interactive process, this refers to the time between the submission of the process until it starts responding. Then next, we have the waiting time. The total amount of time a process is spent in ready queue. So how do we compute the waiting time? We have the turnaround time minus the CPU burst. CPU burst pala guys is the burst time or execution time, or other term is the running time. Hello guys! Welcome again sa ITS, Information Technology Skills. Kung bago ka pa sa channel na to, don't forget to subscribe and hit that notification bell para matuto ka about computer programming and other stuff about computer. Okay, so here, we're going to discuss the first example or the first CPU scheduling. That is the first in, first out, or first come, first serve. Okay? So what is first in, first out? The process which arrives first gets executed first. Or we can say that the process which requests the CPU first gets the CPU allocation first. So, parang pupunta ka lang sa isang restaurant at kung ikaw yung nauna sa pila, of course, ikaw yung una nilang isa-serve. So, let's say this is the CPU. Then, meron tayong dumating na P1 followed by P2 and P3. So, dun sa pila, of course, nauna dyan si P1. Ibig sabihin, si P1 ang unang pupunta dun sa CPU or mag-allocate ng CPU and siya din yung unang lalabas sa CPU. So, that is the first in, first out. So, let's have an example. Let's say we have this table and meron tayong P1 hanggang P5. The arrival time of P1 is 0, P2 is 3, P3 is 4, P4 is 6, P5 is 10. Okay? So, ito yung oras na dumating yung mga processes natin. Then, we have the CPU burst. Ulitin ko, ang CPU burst is the burst time or execution time. Ito yung oras na gagamitin nila yung CPU. Okay? So, para ma-compute natin yung turnaround time and waiting time, kailangan natin gumawa ng Gantt chart. For the first come first serve, ang Gantt chart niya guys, let's say, yan yung Gantt chart, dyan natin ipa-plot yung mga processes natin. Okay, so dahil first come first serve tayo, ang unang dumating is si P1. So at time 0, dumating si P1 and mapaprocess si P1. Ilan yung CPU burst na nagamit niya? We have 8. So that is the time consumed by P1. So kung titingnan natin, at time 8, dumating na rin si P2, P3, and P4. Okay, so si P2 dumating nung 3. 3 minutes siguro on process si P1. The next, 4 minutes na napaprocess si P1, dumating din si P3, and dumating si P4 at time 6. So, dito sa tatlong dumating na yan, ang unang sa kanila is si P2. Ibig sabihin siya yung next sa pila. So, mapaprocess si P2, ang CPU burst niya is 4. So, mangyayari nyan guys, ang time natin is 8 plus 4 na CPU burst ni P2, we have 12. So, at time 10, dumating na rin si P5. Pero, meron pa rin sa pila yung si P3 and P4. So, ang next na mapaprocess is si P3. Ang CPU burst ni P3 is 5. So, we have 12 plus 5, that is 17. Then, next sa pila is si P4. So, process si P4, meron siyang CPU burst na 3. So, 17 plus 3, we have 20. Then, lastly, of course, ang huli sa pila, that is P5, meron siyang CPU burst na 2. So, 20 plus 2, 22. So, ito yung Gantt chart or the arrangement ng process ng mga processes. So, in computing the turnaround time, we have this equation, time finish minus time arrival. Okay? So, ang time finish, guys, is kung saan natapos yung mga processes natin. Like, for P1, natapos siya nung 8. Kay P2, natapos siya nung 12. P3, natapos siya nung 17, and so on. Okay? So, yun ang ilalagay natin. So, P1, time finish niya is 8, ang arrival time niya is 0. So, saan natin titingnan yung 0? Dun sa table, arrival time. So, 8 minus 0, that is equal to 8. The next, we have P2, 12 minus 3. So, saan nakuha si 12? Dun sa Gantt chart, kung saan siya natapos, then the arrival time, which is 3. So, 12 minus 3, that is 9. P3, 17 minus 4, that is 13. So, saan ulit nakuha si 17? Titignan lang dun sa my Gantt chart. Saan nakuha yung 4? Dun sa arrival time ni P3. The next, we have P4, 20 minus 6, that is 14. P5, 22 minus 10, that is 12. Okay, so these are the turnaround time for each process. And if we're going to compute the average turnaround time, ang gagawin lang natin dyan is to add all the turnaround time divided by number of process, which is 5. Let's compute the average turnaround time. We have 8 plus 9 plus 13 plus 14 plus 12. That is the turnaround time ng mga process natin. And ilan yung process? We have 5 process, that is equal to 11.2. The next, we're going to compute the waiting time. Ilang oras daw naghintay yung isang process para matapos siya. So, in computing the waiting time, we have TT, which is the turnaround time minus the CPU burst. For P1, meron siyang turnaround time na 8, that is yung na-compute kanina, minus the CPU burst, titingnan yun sa table. So, 8 minus 8, that is equal to 0. For P2, we have 9 minus 4 equals 5. So, saan nakuha si 9? Yun yung na-compute na turnaround time. The 4 is the CPU burst, so that is equal to 5. P3, 13 minus 5, that is 8. P4, 14 minus 3, that is 11. P5, 12 minus 2, that is 10. Okay, so ibig sabihin ng mga waiting time na to, let's say for P2, naghintay siya ng 5 seconds, let's say 5 seconds, para matapos siya. So, in computing the average waiting time, katulad lang sa turnaround time, add all the computed waiting time divided by number of process. So, we have here 0 plus 5 plus 8 plus 11 plus 10 divide by 5. 5 kasi 5 yung process natin, that is equal to 6.8. The next, we have example number 2. If you're going to observe at example number 2, wala tayong arrival time. Meron lang siyang CPU burst. So, ibig sabihin nito guys, sabay-sabay na dumating si P1, P2, and P3. Let's say magtotropa sila, sabay-sabay silang pumunta sa canteen or sa isang store. Okay? So, pag ganun guys, pipila pa rin naman sila. And we can say that yung arrangement nila dito sa mga process ID, that is the arrangement of the pila. So, in creating the Gantt chart, we can say na ang una dun sa pila is si P1. So, at time 0, of course, si P1 ang sa una, siya ang unang mapaprocess. So, meron siyang 17 na CPU burst. Ang next kay P1, we have P2. Meron siyang 3 na CPU burst. Ibig sabihin, 17 plus 3, that is equal to 20. The next, we have P3. Meron siyang 6. 20 plus 6 is 26. And P4, meron siyang CPU burst na 2. So, ibig sabihin, 26 plus 2, that is 28. So, this is the Gantt chart nung example number 2. Now, let's try to compute for the turnaround time. Lagay lang natin yung equation, baka nakalimutan nyo. So, in computing turnaround time, we have the time finish minus arrival time. So, for P1, we have 17 minus 0. Okay, so 17 at time 17, tapos na si P1. Yun po yung nakalagay doon na time finish. And the arrival time is 0. So, saan nakuha yung arrival time? Wala namang nakalagay dito. We can assume na sabay-sabay silang dumating. And yung time nila is 0. So, 17 minus 0 is 17. Then, P2, we have 20. Yun po yung time na natapos si P2 minus 0. Okay? So, bakit 0 ulit? Kasi sabay-sabay silang dumating nung 4 na processes. Okay? So, 20 minus 0, that is 20. For P3, 26, that is the time finish, minus 0, the arrival time, that is 26. Then next, we have P4, 28 minus 0 equals 28. So now guys, compute naman natin yung average turnaround time. So same dun sa compute natin kay example number 1, we're going to add all the computed time finish divide by number of processes. So we have here 17 plus 20 plus 26 plus 28. Yun po yung mga na-compute natin na turnaround time. And the number of process, we have 4 processes, that is divided by 4, that is equal to 22.75. For the waiting time, we have the turnaround time minus the CPU burst. Okay, so for the process 1, 17 minus 17. Okay, so ang turnaround time ni P1 kasi is 17 minus yung CPU burst niya na titingnan natin dun sa table, that is equal to 0. Then next, we have the process 2. For the process 2, we have the turnaround time na 20 and the CPU burst that is 3. So, 20 minus 3, that is 17. P3, 26 minus 6, that is 20. P4, 28 minus 2, that is 26. So, let's compute for the average waiting time. So, sa average waiting time ulit, guys, gagawin lang natin, we're going to add all the computed waited time and divide by number of process. So, we have here 0 plus 17 plus 20 plus 26 divide by 4. That is equal to 15.75. Okay, guys, let's have example number 3. So, dito we have 5 processes. Then, for the arrival time, nandito, and the CPU burst. Okay, so if you're going to observe kay P3 and P4, sabay silang dumating. Okay, so paano kaya kapag ganun? So, the Gantt chart, at time 0, isa pa lang naman ang nakapila na process. Sino bang dumating ng time 0? That is P1. So, ibig sabihin siya ang may execute. So, P1, meron siyang CPU burst na 8. Okay? So, at time 3, dumating si P2. Then, at time 6, dumating si P3 and P4. So, ang nakapila ngayon is si P2, P3, and P4. Of course, unang dumating si P2, ibig sabihin siya ma-execute na una. Meron siyang CPU burst na 4. So, 8 plus 4, that is 12. So, dito ngayon kay P3 and P4, dahil sabay sila, we can see na yung arrangement na lang nila dun sa pila. So, masasabi natin dito guys that P3 is mas nauna sa pila. Siguro nagbigayan na lang sila, si P3 ang nasa harapan na pila. Okay, so ma-process si P3, meron siyang CPU burst na 5, 12 plus 5, that is 17. So, kung titingnan natin, at time 10, nanditong part na to, sa gitna ni P2, meron na rin si P5. Okay, so hindi pa naman napaprocess si P4, ibig sabihin si P4 ang sunod na ma-execute. So, for the CPU burst ni P4, meron siyang 3. So, 17 plus 3, that is 20. Then, lastly, of course, yung pinakaling dumating si P5. So, si P5, meron siyang CPU burst na 2. So, 20 plus 2, 22. So, compute ulit natin yung turnaround time. Kay P1, natapos siya nung 8, dumating siya nung time 0. So, 8 minus 0, that is 8. Kay P2, natapos siya nung time 12, pero dumating siya nung 3. So, 8 minus 3, meron siyang 9. Then, for P3, 17 minus 6, merong 11. P4, 20 minus 6, that is 14. P5, 22 minus 10, that is 12. Okay, so for the average turnaround time, we have 8 plus 9 plus 11 plus 14 plus 12 divided by 5, that is equal to 10.8. Then, let's compute for the waiting time. For the P1, meron siyang 8 na turnaround time and the CPU burst is 8. So, hindi na siya naghintay pa. Walang nasayang na time sa kanya. Then, for P2, meron siyang turnaround time na 9. Then, meron siyang CPU burst na 4. So, 9 minus 4, that is equal to 5. P3, 11 minus 5, that is 6. P4, 14 minus 3, that is 11. P5, 12 minus 2, that is 10. So, let's compute for the waiting time ng mga limang process na yan. So, we have here 0 plus 5 plus 6 plus 11 plus 10 divided by 5 processes, that is equal to 6.4. So guys, kung gusto nyo mapanood yung shortest job first, don't forget to subscribe and i-click na rin yung video na nakikita nyo dyan sa screen nyo para dun sa iba pang CPU scheduling.